Hi, my name is Johannes Ulrich and I'm working with the SANS Technology Institute. This presentation is a quick introduction in how to assign IPv6 addresses across your network and how to live without NAT. It's also a little bit a teaser for our IPv6 summit that we have coming up in July 15th. This and in particular many other security related topics will be discussed at that summit July 15th in Washington, D.C. So these IPv6 addresses, first of all, they're a lot longer than IPv4. IPv4 was 32 bits and IPv6 is 128 bits. Of course, one of the goals here is to no longer have to bother with NAT. However, these addresses also have to be understood a little bit differently than IPv4 addresses. First of all, the first half of the address is used to identify the network. The smallest net block that you're going to assign to a subnet is a /64. With that, the first half of the address becomes the network address, and the second half of the address becomes the interface ID inside that network. So the complete address is then assembled out of the network ID and the interface ID. We can even break that out a little bit further. Your ISP for an organization with multiple subnets is going to assign you a /48. Then you're going to take the next 16 bits to come up with your internal network IDs. So your network IDs are the assignment that you got from your ISP plus the subnet ID that you assigned internally. And then of course, you have the interface ID to come up with the complete IPv6 address of an individual host in your network. So really the important parts here to start out with is we do have fixed subnet sizes /32, /48, /64, and then 64 is the smallest possible subnet. That sounds pretty big, but really this is all designed around routing efficiency, not necessarily because you need that many addresses in a local subnet. And then with that, we also have a couple of different unicast address types. Unicast addresses are used to address individual hosts. As a host boots up, it will first assign itself a link local address. Link local addresses can only be used on your local subnet. They're not routed at all. Then we have unique local addresses. This is essentially a net block that you assign yourself. You can route it inside your own organization, maybe across partner organizations, but they're not globally reachable. If you want to reach out to the IPv6 internet at large, you will need a global unicast address. So link local addresses, they always start with FE8. The FE8 0/10 net block is set aside for them, and as a host boots up, it will pick one. They're non-routable, they're auto-assigned typically, and they are required. You cannot run IPv6 without at least one link local address, and as such, it's also the first address a host is going to pick as it boots up. And then if you really want to connect to the IPv6 internet, you also need a global IPv6 address. So these addresses are globally routable. They start with 2 or 3. Basically, the subnet set aside for them is 2/3. You will get assigned a net block by your ISP. Maybe you're going to get an allocation from a regional registrar if you need more address space or if you need provider independent address space, just like with IPv4. Now, unique local addresses, they're really in between. The net block assigned to them is FC/7. However, if you pick your own, and you're always going to pick your own here, then the 7th bit is set, so it will be FD or Foxtrot Delta/8. That's really the effective net block used for that. What that's really used for is to have addresses that you can use internally. Compare them to 10 dot addresses that you may use internally, you may route them internally, even though they don't mean anything globally. It came sort of originally out of the idea of site local. Now, site local was part of the original IPv6 RFCs. However, that got then depreciated, and unique local addresses are really supposed to provide the function that site local was supposed to provide, to give you a unique address block that you can use internally and maybe again with partner organizations. So typically they start with FD/8. So let's get started and talk about how are we getting these addresses and how are we assigning them. So first thing you need is you need your global/48. Now that's something you get from your ISP, maybe from a tunnel broker if your ISP does not support IPv6, or you get assignment or an allocation from your regional registrar. So this will look something like this: 2001 DB8/48. And actually this particular net block, 2001 DB8, is just set aside for examples like this. Next, you're going to pick yourself a unique local address. Now, there isn't really terribly lot of guidance how to do it. Just start with FD and then pick something random. Now, there are some algorithms that you're supposed to use, but really what it comes down to is the next 32 bits here are random to minimize the chances that someone else picks the same block. But even if someone else happens to pick the same address block, chances that it'll hurt you are low, unless of course down the road you do want to route these unique local addresses with this other organization. So the RFC actually specifically says you should not pick something like 111112222, but pick something random. Now, okay, so we got our unique local addresses, we got our global addresses. How are we going to use them in our network? Let's first talk a little bit about who is talking to whom in our network. And I got a little network here that sort of has the basic components. On the left, you have sort of a sales department, and you probably have more than one subnet like that for different departments in your organization. It's connected to an internal router. And then we also have some shared servers here, maybe a file server, network printers, things like that in a second subnet. Then we got a demilitarized zone here with a couple of servers, maybe a mail server, a web server, and finally a border router that connects us to the internet at large. So who has to talk to whom? Well, our internal network definitely has to talk to these shared internal resources, these workgroup servers, and it has to talk to DMC, for example, to the mail server that we have in there, DNS server, and a couple resources like that. The DMC itself has to talk to the outside and probably also has to accept incoming connections from the outside if we have, for example, a mail server sitting there or something like a web server. The real question is, does our sales department need direct access to the outside? And I would like to argue that they probably don't. And that's kind of what we try to accomplish sometimes with NAT, where that sales department, those workgroup servers, they use NATed addresses and then they're going through some kind of NAT router. A better solution, of course, would be to actually isolate that internal network by making it go through proxies. So where instead of going directly outbound and through some NAT translation, that sales department really can only connect to the internal mail server, maybe to an internal HTTP proxy server, in order to get internet access. So let's put this together in a little matrix like this. Our sales department, it needs to be able to reach these workgroup servers and the demilitarized zone. Whether or not it needs to reach the internet, well, that depends on how we set up the DMC. If there is an HTTP proxy server and other servers that essentially implement proxies for other protocols in the DMC, then really that sales department doesn't need direct internet access. The workgroup servers, well, they need access to the sales department. We have things like backup servers and such in there too that reach out and pull data in. And then, of course, they need access to the DMC, again, for email connectivity, maybe some DNS servers and things like that. The DMC itself really only needs outbound access to the internet. Everything coming from the sales department or the workgroup servers is probably going just to the DMC, not from the DMC back, and we're sort of assuming sort of stateful filtering here. Now, from the internet, we only connect to the DMC. The DMC is the only part that's directly exposed to the internet. Now, what does that mean for our address allocations? Again, remember, we have three kinds of unicast addresses. Global addresses that are directly reachable from the internet. We need those for direct unproxied internet access. If we go through a proxy, we really only have to reach the proxy. We don't have to reach the final destination. Unique local addresses, we need that for all hosts that need to talk across subnets. And then link local, well, we need that for everybody, so we can't do without link local. So the sales department, for example, it doesn't really need a global address. We can just assign it a unique local address. And then we use a proxy in our DMC to actually connect to the internet. So really what we get by doing that, by not assigning a global address to the sales department, is real isolation. That's actually better than what we had with NAT. With NAT, there was always a chance for these hosts to connect directly outbound. That can't happen anymore if they don't have a routable address, and there is no NAT that would translate that non-routable address into a routable one. Same for the workgroup servers. All they need is a unique local address in order to be able to be reached from other subnets. They don't need direct internet access. Now the servers, our DMC, they of course need a global address for internet connectivity, and they need a unique local address so our other subnets can connect to them. And that's no problem in IPv6. An interface may have multiple addresses. Now, one little trick we can play here is that, for example, our SSH server only listens on the unique local address, so now it cannot be reached from the internet. And then, of course, if you do want to connect from the outside to, for example, a remote managed system like that, well, you probably should go through a VPN, and you can route unique local addresses over your VPN. So that policy would automatically be enforced by only having that SSH server listen on the unique local address. So as a quick summary, don't just be too afraid by no more NAT. Take it as a chance to really think about how can we use this new protocol and all the possibilities it provides to actually end up with a more secure architecture than we had with NAT. Nobody's willing to admit it. Everybody kind of uses NAT as a security feature. It's not. It's not supposed to be a security feature. It's really just a hack, a workaround to make our systems work with the limited amount of address space that we have available. And then remember, one host can have multiple addresses in IPv6, so we are no longer limited to virtual interfaces and things like that. Here are a couple URLs to help you along with this. 6.net has a little tool to come up with a unique local assignment for you. It's essentially a random number generator that follows the specification, the RFC, and uses the timestamp and a MAC address as seed to avoid overlap. And then here a link to the RFC that describes unique local addresses. Thanks for your time and for listening to this quick 5-minute presentation. And again, remember our summit on July 15th. Here's also my email address in case you have any comments or questions.